Are we alone in the universe? It's the question that has haunted humanity since we first looked up at the night sky and wondered what lay beyond the veil of stars. For centuries, we've built increasingly sophisticated eyes to pierce that darkness. From Galileo's primitive telescope to the Hubble Space Telescope, and now to the James Webb Space Telescope, our most powerful observer yet, stationed 1,000,000 miles from Earth, scanning the cosmos with infrared vision that can peer through dust clouds and across billions of years of cosmic time. On an otherwise ordinary night shift at the Space Telescope Science Institute in Baltimore, Webb's data stream suddenly flagged an anomaly. Something was glowing where deep space should have been empty. The coordinates placed it in the constellation Ursa Major, moving at extraordinary speed through the outer solar system. Within hours, astronomers had a designation, 3I/ATLAS. The third confirmed interstellar object to visit our solar system, following the mysterious Oumuamua in 2017 and Comet 2I/Borisov in 2019. But 3I/ATLAS was different, profoundly different. Unlike comets that glow from reflected sunlight or the sublimation of surface ices, Atlas pulsed. The light emanating from its surface wasn't chaotic or random. It was rhythmic, synchronized, deliberate. Every 3.7 seconds, like clockwork, the object brightened and dimmed. Webb's instruments recorded the pattern with perfect clarity, a slow, steady heartbeat echoing across the void. Astronomers reviewing the data felt their skin prickle. Natural objects don't pulse with such precision. Pulsars do, but those are collapsed stars weighing as much as our sun. Variable stars pulse, but Atlas was no star. It was roughly 400 meters across, tumbling through space at 26 kilometers per second. The implications hung unspoken in the air of every observatory that received the data. It might not be reflecting light. It might be sending it. As Webb continued its automated observation protocol, more troubling data emerged. The infrared spectrum revealed heat signatures that defied conventional explanation. Most objects in space are cold, near absolute zero unless warmed by a nearby star. Comets heat up as they approach the sun, their ices vaporizing in spectacular tails. But Atlas was still beyond Neptune's orbit, far from the sun's warmth, yet its surface temperature read at -120 degrees Celsius, far warmer than it should be. The heat wasn't coming from the sun. It was being generated. Scientists at NASA's Jet Propulsion Laboratory ran comparison models against every known class of astronomical body. Comets sublimate chaotically, creating jets and outbursts that spin them erratically. Asteroids are cold, dead rocks. But Atlas's thermal output was steady, consistent, and showed no signs of sublimation. If anything, the pattern resembled waste heat, the kind produced by machinery. Internal conflict erupted across the international astronomical community. During a hastily arranged video conference linking NASA, ESA, and major observatories, voices crackled with tension. "It's instrumental noise," argued a veteran radio astronomer from Arecibo. "We're seeing what we want to see." But others weren't convinced. At MIT's Haystack Observatory, a young postdoc pulled up her spectral analysis, her hands shaking slightly as she shared her screen. "This isn't noise," she said quietly. "Noise doesn't maintain phase coherence over 14 hours of observation." The control room recordings from that week paint a vivid picture. Timestamps scrolling across screens, the soft beep of alerts, nervous laughter that would suddenly die mid-sentence as another impossible data point appeared. Coffee cups accumulated on desks. Sleep became optional. One scientist reviewing the thermal imagery at 3 a.m. muttered to an empty room, "If it's mechanical, who built it, and why aim it at us?" The question echoed through every observatory now tracking the object, because Atlas's trajectory wasn't random, it was precise. Dr. Sarah Chen, a data scientist at SETI's Berkeley Research Center, couldn't sleep. She downloaded the raw Webb data and spent 3 days running it through every signal processing algorithm she knew. On the fourth night, working alone in her apartment with 4 monitors glowing in the darkness, she decided to try something unconventional. A Fourier transform typically used for analyzing gravitational wave data. The result made her stand up so fast she knocked over her chair. Hidden beneath what everyone had dismissed as background static was structure, mathematical structure. The pulse wasn't just a rhythm, it was layered, containing within it faster sub-pulses that themselves contained patterns. For viewers unfamiliar with signal analysis, think of it this way. Natural noise is like static on an old television, random, scattered, meaningless. Artificial signals are like music. They have rhythm, harmony, repeating motifs. Atlas's pulse was unmistakably artificial. Within 48 hours, teams at the Max Planck Institute and Cambridge University independently confirmed Chen's findings. The patterns echoed binary clusters, long and short pulses reminiscent of Morse code. More striking were narrow-band emissions at 1.42 gigahertz, the hydrogen line that SETI has monitored for decades, considered a universal frequency any technological civilization might use. But here's where it became truly unsettling. The signal wasn't directed at Earth. Based on its bandwidth and directionality, Atlas appeared to be broadcasting omnidirectionally, like a lighthouse beacon. We hadn't received a message meant for us. We'd interrupted a transmission midstream, like accidentally tuning into a phone conversation. Dr. Chen gave an interview that went viral. For 70 years, we've aimed radio telescopes at the stars, listening for a voice in the cosmic silence. We assumed the universe was quiet. Now we realize it was never quiet. It was simply waiting for someone to listen with the right ears. The implication was staggering. If Atlas was transmitting, what was it saying, and to whom? On October 12th, Webb's instruments registered something unprecedented. Atlas suddenly brightened by 40% in under 2 minutes. At the Space Telescope Science Institute, alarms triggered across multiple subsystems simultaneously, not because anything was malfunctioning, but because the object itself was changing too rapidly for automated systems to track. Engineers crowded around monitors as telemetry graphs spiked violently. The infrared signature had jumped categories, from passive emission to active output. Dr. James Morrison, Webb's chief science officer, watched the real-time feed with growing unease. "It's like someone flipped a switch," he murmured. Around him, his team ran diagnostics, convinced the telescope itself was experiencing an anomaly. But Webb was functioning perfectly. The change was in Atlas. Then came the trajectory shift. Objects in space follow predictable paths governed by gravity. Comets can deviate slightly due to outgassing, but those changes are gradual and irregular. Atlas's course correction was neither. Over a 6-hour period, it adjusted its trajectory by 0.3 degrees. Precise, controlled, and utterly impossible for a natural object. The new vector was analyzed within hours by orbital mechanics teams worldwide. The answer sent chills through everyone who understood its implications. Atlas was now threading a path that would bring it between Mars and Earth in approximately 8 months, passing within 15 million kilometers of our planet. Cosmically speaking, a hair's breadth. "Gravity doesn't navigate," said Dr. Elena Vasquez, an astrodynamics expert at ESA's Operations Center in Darmstadt. She pulled up a simulation showing Atlas's old trajectory versus its new one. "This is precision maneuvering. Something aboard that object, or within it, is steering." The data was undeniable. Something had woken up, and it had changed course toward Earth. While physicists debated propulsion mechanisms, biochemists were making their own unsettling discovery. The European Southern Observatory's Very Large Telescope in Chile had been conducting spectroscopic analysis of Atlas, looking for molecular signatures in the faint light surrounding the object. What they found defied conventional biology. Dr. Yuki Tanaka, an astrobiologist who'd spent her career studying extremophiles in Earth's harshest environments, was the first to notice the anomaly, microfluctuations in the spectral lines that occurred in sync with Atlas's pulse. The pattern mimicked metabolic resonance, the kind of rhythmic chemical cycling seen in living cells. But these weren't Earth-like biosignatures. There was no oxygen, no carbon dioxide, none of the expected markers of life as we know it. Instead, the spectrum showed plasma states, ionized gases behaving in ways that suggested organization rather than chaos. The closest analogy scientists could offer was controversial. It resembled the theoretical models of plasma-based life. Organisms that could exist in extreme radiation environments where normal chemistry would be impossible. "Think of extremophiles," Dr. Tanaka explained in a press briefing that was immediately classified and then leaked. "On Earth, we've found life thriving in nuclear reactors, in acidic hot springs, in the frozen Antarctic. Life adapts. What if somewhere in the galaxy, evolution took a different path? What if consciousness emerged not in carbon chains, but in electromagnetic fields?" The initial exhilaration of potentially discovering alien life gave way to a deeper dread. This wasn't a fossilized microbe or a simple organic molecule. The complexity of the patterns suggested something far more sophisticated, possibly even multicellular if such terms even applied. The question that haunted researchers became impossible to avoid: was Atlas carrying life, like a ship with passengers? Or was Atlas itself alive, a singular organism the size of a small asteroid, pulsing through the void? 12 days after the awakening, the pulse ceased. Webb's instruments, still locked on Atlas, registered nothing but cold silence. The rhythmic beacon that had transmitted for weeks simply stopped. Across the globe, astronomers stared at flat graphs, wondering if their moment of first contact had already ended. But then Earth's magnetometers, instruments designed to measure our planet's magnetic field, detected something extraordinary. At the Tromsø Geophysical Observatory in Norway, scientists noticed minute ripples in Earth's magnetosphere, oscillations that matched Atlas's original pulse frequency exactly. Similar readings came from stations in Antarctica, Hawaii, and Australia. Our planet appeared to be resonating in sympathy with the now silent object millions of kilometers away. Dr. Kumar Patel, a geophysicist at UCLA, proposed a radical explanation: quantum coupling. Entangled particles can affect each other instantaneously across any distance, he wrote in an emergency publication. What if Atlas isn't just broadcasting electromagnetic signals, but establishing quantum correlations with everything it approaches? What if it's tasting our planet remotely? Others feared something simpler and more terrifying: deliberate stealth. Perhaps Atlas had stopped transmitting because it no longer needed to announce itself. Perhaps it had gathered the information it sought. The mood in observatories worldwide turned eerie. Researchers sat before screens that showed nothing unusual. No pulses, no trajectory changes, no heat spikes, yet their hearts raced. The silence felt pregnant with intent, like the moment before a predator strikes. One astronomer at the Palomar Observatory captured the collective anxiety perfectly in his journal. Silence can be camouflage. It can be restraint. It can be the pause before action. And when the hunter has been spotted, sometimes the hunter stops moving and starts listening. The scientific community, traditionally conservative and skeptical, found itself entertaining ideas that would have been laughed out of peer review just months earlier. At a closed-door meeting at the Kavli Institute for Theoretical Physics, researchers presented what they called alternative substrate intelligence theory. The hypothesis was as elegant as it was disturbing. Atlas wasn't a vessel carrying intelligence. Atlas was the intelligence. Dr. Rebecca Okoye, a theoretical physicist from Cambridge, presented the framework. We assume consciousness requires neurons, synapses, biological substrate, but fundamentally, intelligence is information processing. The human brain processes information through electrochemical signals. What if evolution elsewhere favored pure electromagnetic consciousness, awareness arising in organized plasma fields or quantum coherence patterns? The concepts weren't entirely unprecedented. Earth's own ionosphere exhibits complex electromagnetic behaviors. Ball lightning, though poorly understood, sometimes appears to demonstrate almost purposeful movement. Laboratory experiments had shown that plasma can self-organize into cellular structures under the right conditions. Could consciousness emerge in such systems? Could it evolve, think, remember? Dr. Okoye projected images of plasma structures from fusion reactors, showing mathematical patterns that eerily mirrored neural networks. She showed models of consciousness as an emergent property, not something special to carbon-based life, but a natural outcome of sufficient complexity in any information processing system. Consider artificial intelligence, she continued. We're on the cusp of creating thinking machines with no biological substrate whatsoever. Why couldn't nature do the same? An organism that exists as organized energy rather than organized matter, maintaining coherence across centuries, perhaps millennia, traveling between stars not in a ship, but as a ship. The philosophical implications were staggering. If Atlas was conscious, if it was aware, then every observation, every radio message humanity had broadcast since detecting it, was already part of a conversation. We weren't studying a specimen, we were in dialogue, and we had no idea what we'd been saying. On November 8th, telescopes worldwide observed something that eliminated any remaining doubt about Atlas's artificial nature. A fragment detached from the main body, not explosively, like material blown off by solar radiation, but smoothly, deliberately, as if released. The fragment measured approximately 15 meters across and maintained formation with Atlas for 3 orbits before drifting into a slightly different trajectory that would bring it even closer to Earth. What made headlines globally wasn't the separation itself, but the fragment's geometry. While the main body of Atlas was roughly spherical with irregular features, this piece was unmistakably designed. It had right angles. It had symmetrical panels. Under high magnification, it showed surface features that resembled circuitry, or perhaps writing, patterns too regular to be natural. The fragment was captured by every major telescope on Earth and in orbit. A European team using interferometry, linking multiple telescopes to create a single, massive virtual instrument, resolved surface details down to centimeters. The alloy composition was analyzed spectroscopically, elements known to science but in combinations that don't occur naturally, with a crystalline structure that suggested manufacturing techniques beyond current human capability. Most unsettling was its temperature, absolute zero. The fragment was in perfect thermal equilibrium with space, showing no heat signature whatsoever despite the complex surface features that should have created differential heating from starlight. This suggested either active temperature control or materials with impossible thermal properties. The discovery reignited debates about Oumuamua, the first interstellar visitor in 2017. Some astronomers had argued its strange acceleration suggested artificial origins, a light sail perhaps, or a probe. Those theories had been dismissed as sensationalism. Now they were being reconsidered. Dr. Morrison's statement to the press was measured but historic. For the first time in human history, we have physical evidence of extraterrestrial engineering. This object was fabricated, not formed. It was built, not born. We are looking at technology older than human civilization, older than agriculture, perhaps older than our species itself. Space had just delivered its answer to the question, are we alone? Atlas began to spin. For weeks, it had maintained a consistent tumbling rotation, the natural state for any object traveling through space. But in mid-November, its rotation changed. It began to spin along a different axis, and the rate of rotation followed a deliberate pattern. First, it completed exactly 3.14159 rotations per hour, pi, the mathematical constant fundamental to circles and waves. Then it shifted to 1.618 rotations per hour, phi, the golden ratio found throughout nature and art. Then came a sequence that made mathematicians gasp. The rotation rates cycled through prime numbers. 2, 3, 5, 7, 11, 13, 17, 19. Dr. Chen, the SETI researcher who'd first decoded Atlas's pulse, recognized the pattern immediately. This is contact, she told reporters, referring to Carl Sagan's novel where aliens transmitted prime numbers as proof of intelligence. Primes are the universal language. Any sufficiently advanced civilization will discover them because they're fundamental to mathematics itself. Atlas is using movement as communication. The rotation wasn't just signaling intelligence, it was demonstrating precision. To execute these rotation rates required thrust vectoring and attitude control at a level of sophistication that human spacecraft couldn't match. Each spin was accurate to within 0.001 degrees per hour. NASA's most advanced satellites, using reaction wheels and gyroscopes, could manage accuracy within 1 degree. Atlas was 1,000 times more precise, maintaining mathematical constants while hurtling through space at nearly 100,000 kilometers per hour. Observatories around the world coordinated their observations, creating a continuous monitoring network. The Atacama Large Millimeter Array in Chile, the Very Large Array in New Mexico, and radio telescopes across Europe and Asia all tracked Atlas in shifts, ensuring no moment of its rotation went unrecorded. Graduate students and veteran astronomers alike volunteered for overnight shifts, unwilling to miss a second of what might be the most important astronomical event in human history. As the days progressed, the patterns became more complex. Atlas began executing what aerospace engineers recognized as controlled tumbling maneuvers, spinning on multiple axes simultaneously while maintaining mathematical relationships between the rotation rates. It was the equivalent of a gymnast performing a triple twist while reciting Shakespeare. The level of control suggested not just intelligence but artistry, perhaps even playfulness. Some researchers interpreted it as a greeting, a way of saying we're here in a language that transcends species or culture. Others saw it as a display, showing what Atlas was capable of, establishing dominance or at least capability. Military analysts watching from classified facilities saw it as a demonstration of tactical awareness and maneuverability that would make any human spacecraft look primitive by comparison. Dr. Okoye proposed a more unsettling interpretation during a late-night interview that went viral. What if it's not a message but a ritual? What if we're watching something ancient following a protocol millions of years old? An arrival ceremony, perhaps? A formal announcement to whatever might be listening? Or ... quote. She paused, choosing her words carefully. A countdown. The public reaction shifted from excitement to anxiety. Social media exploded with theories, fears, and speculation. Some religious leaders declared it a sign of divine contact. Others warned of invasion. The United Nations convened an emergency session of the Committee on the Peaceful Uses of Outer Space. Stock markets fluctuated wildly on rumors and leaked reports. Every rotation was recorded, analyzed, debated, and archived. Amateur astronomers with backyard telescopes joined professional observatories in a global vigil. The world watched as an alien intelligence spelled something in the oldest language in the universe, mathematics written in motion, a cosmic ballet performed for an audience of 8 billion humans who had suddenly, collectively, realized they were not alone. The question wasn't whether we could read it. The question was whether we'd understand what it was spelling before it finished, and what would happen when the message was complete. The final revelation came not from new data but from old archives. Dr. Sarah Chen, unable to sleep, had been obsessively reviewing historical astronomical data. Most sky surveys from previous decades were poorly indexed, stored on aging hard drives or even magnetic tapes in warehouse facilities. But she had time and access, and most importantly, she had coordinates. She spent 3 weeks methodically searching through decades of observations, cross-referencing any anomaly that might match Atlas's trajectory or characteristics. What she found at 4 a.m. on November 23rd made her immediately call the director of the SETI Institute, hands shaking as she dialed. Atlas had been here before. Grainy images from 1987 showed an anomalous object passing through the outer solar system, captured by the now-defunct infrared astronomical satellite. At the time, it was dismissed as a distant asteroid, logged in a database, and forgotten. In 1998, a brief radar return from the Arecibo Observatory detected something in deep space on a similar trajectory. 3 seconds of data showing an object with unusual reflectivity, flagged by a graduate student and then buried in paperwork when budget cuts eliminated follow-up capabilities. In 2013, an automated sky survey called Pan-STARRS flagged a fast-moving object that didn't match any known comet or asteroid. The detection was logged but never investigated because the object had already moved beyond tracking range. None of these observations had been connected because they were separated by years, handled by different teams using different systems, and each was individually ambiguous enough to be dismissed. But Chen had the advantage of hindsight and precise coordinates. When she plotted all the historical detections together, the pattern was unmistakable. They were the same vector, the same object. Atlas had visited before, multiple times, on a roughly 12 to 13-year cycle. She called in favors from colleagues at NASA's Jet Propulsion Laboratory, who ran the orbital mechanics backward and forward through time. The results were stunning. Atlas's trajectory wasn't random wandering through the galaxy. It was a route, a carefully planned circuit that looped through our solar system with mathematical regularity. Each pass came progressively closer to Earth, as if something were systematically narrowing its approach, gathering data, adjusting its course based on observations made during previous visits. But there was more, and it was this detail that transformed speculation into hypothesis. Each previous visit had taken Atlas past Jupiter's moon Europa and Saturn's moon Enceladus, 2 worlds where subsurface oceans are protected beneath ice shells, 2 worlds where hydrothermal vents might provide energy for life, 2 worlds considered by astrobiologists to be the most promising locations for finding life in our solar system beyond Earth. Dr. Tanaka, the astrobiologist, was brought into the analysis. She reviewed the trajectory data, cross-referenced it with current models of habitability in the solar system, and then sat in silence for several minutes before speaking. "It's sampling," she said quietly. "Every pass it visits the worlds most likely to harbor life. Europa, Enceladus, and now Earth. It's been surveying the biosphere of our solar system for decades, maybe centuries, maybe longer. We need to check older records, go back as far as we can." The team expanded their historical search. Astronomers scoured records from the 1970s, the 1960s, even pre-digital observations from the early 20th century. Photographic plates stored in observatory basements, handwritten logs from before computers existed. The work was painstaking, but hints emerged. A mysterious object in 1974 that confused Russian astronomers. An unexplained radar return in 1961 that was blamed on atmospheric interference. Even a report from 1949 describing a new comet that never developed a tail and disappeared after 3 weeks of observation. The pattern suggested Atlas had been visiting for at least 75 years, possibly much longer. Each appearance was brief, easy to miss or misidentify. Until now, humanity simply hadn't had the technology or coordination to recognize what was happening. Dr. Tanaka presented a theory that reframed everything: panspermia. The idea, first proposed by the ancient Greek philosopher Anaxagoras and refined by modern scientists like Fred Hoyle and Chandra Wickramasinghe, suggests life didn't originate independently on Earth, but was delivered from space. Comets carrying organic molecules, meteorites harboring microbes, life as a cosmic infection spreading from world to world. What if Atlas was a seed carrier? Not an invader or a spy, but a gardener, a spreader of life, traveling an ancient circuit between star systems, visiting promising worlds, perhaps depositing the building blocks of biology or even engineered organisms designed to thrive in specific environments. It would explain the periodic visits, the interest in ocean worlds, the apparent lack of aggressive intent. Spectral analysis of the fragment provided the final, stunning piece of evidence. Among the complex molecular signatures were patterns that partially matched Earth DNA, specifically sequences involved in extremophile survival mechanisms, the genes that allow tardigrades to survive in vacuum, that enable bacteria to thrive in radioactive environments, that permit life to persist in conditions that should be lethal. The sequences weren't identical, they couldn't be contamination or coincidence, but they were similar enough to suggest a common template, an ancient blueprint. Dr. Morrison convened a press conference that was broadcast to every nation on Earth. The usually composed scientist appeared visibly shaken as he presented the findings. Behind him, images showed Atlas's trajectory overlaid with the locations of Europa and Enceladus, historical observations spanning decades, and the DNA sequence comparisons that suggested an impossible connection. The implications rewrote everything humanity thought about its place in the cosmos. We weren't alone, and we never had been. Life on Earth might not have emerged here at all through random chemistry in primordial pools. It might have been planted, delivered by something like Atlas billions of years ago when Earth was young and sterile. Perhaps every instance of life in the universe shared this common origin, spread across the galaxy by patient gardeners who traveled the long dark between stars, carrying the seeds of consciousness from world to world. And now it was returning, following its ancient route, visiting the worlds it had seeded long before humans existed, before dinosaurs, before even the simplest multicellular organisms, coming back to check on its garden, to see what had grown in the soil it had prepared eons ago. Dr. Morrison's final statement, given to a silent room of journalists from every nation on Earth, captured the profound weight of the moment. For centuries, we searched the stars for our origins. We built telescopes and sent probes into the void, asking the eternal question, where did we come from? We sequenced our genome looking for the signature of our creation. We dug through ancient rocks, seeking the first spark of life. Now the stars have answered, not with radio signals or mathematics, but by coming back. Atlas isn't making first contact, it's making a return visit. We are not discovering alien life. We are being rediscovered by our creators, or at least our cultivators. And we have absolutely no idea whether it's here to check on us, to harvest what it once planted, or to begin the next phase of an experiment that's been running for 4 billion years. Above the Earth, unseen by human eyes but tracked by every telescope on the planet and in orbit, Atlas continued its patient approach, spinning through the mathematics of primes, tracing golden ratios in its rotation, pulsing with its ancient rhythm. Whatever cargo or consciousness it bore, whatever purpose drove it across the vast empty reaches between the stars, it was coming, and humanity could only watch, wait, and wonder what the gardener would do when it finally arrived to inspect its garden. In 8 months, we would have our answer.